All right, 55. So I have f of x equals x cubed minus 2x squared plus x minus 1 over 2x minus 1. So I have to find intercepts, analyze, and graph the given rational function. So let's do first. Can that be factored at all? No, nothing can be factored, right? So first thing, let us find the vertical asymptotes. What do I do there? 2x minus 1 equals 0. So x is 1/2. That's a vertical asymptote. How do I know it's not a whole? Nothing cancels out with that. If it had canceled out, it would be a whole, but because it doesn't, it's a vertical asymptote. What does that tell me about my domain? It can't be what? 1/2. So how do I say that? If you had something like x plus 5, x plus 3, x minus x plus 3, x minus 1. Those cancel, so that would be a whole at -3. So it would still be left out of my domain, but it's not a vertical asymptote. It's just a whole. Yes. Yes. But both of them, so x can't be 1 and x can't be -3. Both of them would be left out of the domain. But only one of them is an asymptote. Just negative. Does that make sense? How about horizontal asymptotes? Slant. It's slant, which puts me in a whole different predicament, right? I have to go through now and divide cubed minus 2x squared plus x minus 1. What do I multiply 2x by to get x to the third? 1/2 x squared. What the heck? Multiply through x to the third minus 1/2 x squared. That gives me, or -5/2 x squared plus x. Now what? Could. Now what? What do I do? What do I need to multiply 2x by in order to get -5/2? Actually, wait, that's not right. Why is that not right? So what is it? It's actually -2 plus 1/2. Yes, or right. Same predicament though. What do I do? What do you multiply 2 by? What can I multiply 2 by to get, so I'll call that x, to get -3/2? So what'd you do? Divide it by 2. Divide 3/2 by 2. And you get what? Or 3/4, right? Divide by 2, divide by 2. Are y'all caught up in the fraction part of this? I think is what I'm trying to say. Negative 3/4. So I need a negative 3/4 x. Because now if I multiply that around, I get negative 3/2 x squared minus 3/4 x. Again, though, I'm subtracting. The rules are the same, it's just that I got fractions in here. Is that a negative 1? Not sure. Okay. Yes. I couldn't read my own writing. So now what is 1 minus 3/4? 1/4. Same scenario. Y'all look like zombies. Why? Because of the fractions? What do I need to multiply 2 by to get 1/4? 1/8. Positive 1/8. At this point, it doesn't matter multiplying around because that's just going to give me a remainder, and I don't have to worry about a remainder. So this is my slant asymptote. This one was hard. Because when you're top heavy, if you divide them, what you get when you divide, not counting your remainder, is your slant asymptote. Yeah, no, the stuff up top. So remember yesterday, didn't I show y'all that one with the parabola that was an asymptote? What was that third block? I showed y'all that in a minute. So this has got a parabolic asymptote. Like that. Yes. Oh. I'm gonna graph it first as normal, and then I'll graph the parabola on here and let you see the difference. It is hot. 2x to the third minus 2x squared minus x plus 5. Is that the right one? 56. Which one are we doing? I looked at the wrong one in your book. X to the third. Y'all let me type that whole thing before you said anything. 2x squared minus 2x squared plus x minus 1 divided by 2x minus 1. So this has a parabolic asymptote about like my pen is tracing, but let me actually graph it for you and show you what it looks like. So it is 1/2 x squared, 2.5, so I don't have to do it. 1/2 x squared minus 3/4 x plus 1/8. Now do you see it? Well, once I divided it and I got my slant asymptote, I just graphed it so you can see. So you see how it's down. Remember, it bounces in behavior, so it bounces into the graph. And the more you zoom out on it, the more you should see they become almost the same graph. You can't even tell the difference anymore once you get so far out. Does that make sense? Yes, no, maybe so. Yeah. It could be. You won't have one quite that difficult with the fractions. Yes. Yes. Let me finish this one. Let me finish this one, and then I'll do 52. Unless you get an imaginary value, in which case it wouldn't. All right, so that gives me the vertical asymptotes. That gives me the horizontal asymptotes, which are none. The slant asymptote, the domain. How about the x-intercepts? You set the top to 0. That's exactly right. So this doesn't factor. It's not a quadratic. And I'm not super keen on, with this one, PRZ, because I'm not even sure that it would have an exact PRZ. How might I find that? How might I find that? I would graph that. I would graph that and find the x-intercepts for sure. If you can show it algebraically, yes. So if it's factorable, I'm not gonna make you PRZ. Come on. Brett, you're awful quiet over there today. What? That's not nice. Oh, your calculators are going to work a little better with mine. But yes, use your calculator to find the zeros. Yes, the top, where the top is 0. No, I'm fixing to show you. All right, so that's right. Thank you. How do you do the end behavior without graphing? Can you do the end behavior without graphing? The end behavior without graphing, yes, because the end behavior without graphing would be the end behavior of the slant asymptote. Because that is an end behavior model. Okay, yeah, so look at this one, for example. Did y'all hear the question? Because you will have to do that. Okay, the question was, can you do the end behavior without graphing? So how do you do it? Well, remember, when we find horizontal asymptotes or slant asymptotes, we're talking about what the end of the graph is doing. So what that asymptote is doing is what the end of this graph is doing. So in other words, this graph is going up on the right and up on the left, or that my asymptote is, that parabola. So this is what my graph is doing also, because it mimics that behavior. It hugs that asymptote. Yes. Okay, but for this one, right. Now, what you can do is you can say, well, I've already divided it. Okay, so 2 ways to do it, really. I've already divided, but you're doing the same thing. The end behavior here based on that would be based on the slant asymptote, right? Because it's telling you to divide. When you divide, you get 1/2 x squared minus 3/4 x, right? And whenever you do it, you base it on the first term. So you're looking at a positive even, both ends going up. Yeah. So it's the limit as x approaches infinity of f of x equals positive infinity. And the limit as x approaches negative infinity of f of x is positive. If it has a what? That doesn't, the whole would not affect the end behavior. If you had a hole where something canceled out, that doesn't impact your end behavior right now. Yes, but it would impact your domain.
It wouldn't impact that.
Right. Yeah, let me finish this one.
What about the thing where there's limit x approaches a number with a minus sign?
That's a vertical asymptote. That's the definition of a vertical asymptote.
Okay, are we gonna have to write like that?
You could have to interpret what it means. So on this one, if x equals 1/2 is a vertical asymptote. I know that, right? But I need the graph to show me which way it goes. So if x equals 1/2 is a vertical asymptote, I'm going to look at the graph. 1/2 here, right? From the left side, here's 1/2. From the left, what does it approach? The red is what I'm looking at. The left side of the asymptote. When you're looking down on it, the left side of the asymptote. It's going towards the asymptote. Always towards the asymptote. So but we want to do limits. So the limit as x approaches 1/2 from the left, it's positive infinity because it's going up. Here's 1/2, right? So if that's a line, if I go on the left side's over here. As I get closer to the asymptote from that side, what is the graph do? Going up, so it's positive. Because we're not talking right now, we're talking about an asymptote, right? So now as x approaches 1/2 from the from the right, because it was plus, so look at this side. So as I come in from the right and I get closer and closer to the asymptote, what happens? It goes down. What is that? 1/2. Yes. 1/2. And remember, we already found that. We found that here. So that would mean that the limit as x approaches 1/2 from the right is negative infinity. Tells you from the right or the left. This means from the left. This means from the right. The right side and the left side of the asymptote of this 1/2. So if you're talking about from the left, the minus, you go to the graph and you say, okay, here's 1/2, right? If I'm talking about the minus, I'm looking at the left. So on the left side, as I get closer and closer to 1/2, what does the graph do? How about y-intercepts? You make x 0. What was what? There was only one. 1.755, yeah. If it can't be factored, or you can't use quadratic formula, you'd have to graph it to see the intercept. You would set the top to 0. Right now, unless you did PRZs, you don't really have enough tools in your toolbox to solve that algebraically. Top to 0 is your x-intercept. Bottom to 0 are your vertical asymptotes unless there's holes. And then, of course, the y-intercepts. That's when I plug 0 in for x, right? So f of 0. Back to my original function and put in a 0 for every x. What do you get? It's easier to see unfactored when you do it this way. 0, 0, 0, negative 1, 0, negative 1. Mm-hmm. Yes or no on that one? You don't have a choice. Okay, well, 50% of this is algebra 2. I'm sorry. Linear factorization is the most important part from that, where we factored down and got it in complete factorization. Which it what? Yeah. This one was not complicated other than the fraction when you divided. Other than that, yeah. Yeah. Yep. No. 57? Intercepts. Do that first. All right, intercepts. First thing would be your, which one did you do first? X-intercepts? X-intercepts would be when y is 0, yes? And y is 0 when the top is 0. Do you agree or disagree? Agree. So when is x to the 4th plus 1 equal to 0? That doesn't work. You're exactly right. Why does that not work? It's imaginary. There are no x-intercepts here. Yep. If you get imaginary numbers as your answer, then there are none. You're not graphing imaginary numbers. You're graphing real numbers. No. There can't be. That's why we say there are none. Because because this is an even number. If you raise anything to an even power, so you multiply it the same number of times, will you ever get a negative number back? No, because negative 1 times negative 1 would be a positive 1, and then times negative 1 again, and times negative 1 again. You'd end up back, every even increment, you'd end up back in a positive number of negative 1, which would be negative 1. So yes, this problem would be completely different if up top were x cubed plus 1, because that could equal 0. Yes. Now y-intercepts, remember that's where I do f of 0. So I plug 0 in for x, right? So it's just 1. So it's never crossing the x-axis, but it is crossing the y-axis, and it's crossing it at the point 0, 1. How about vertical asymptotes? Everybody's got that down pretty easy. Poles? None. Why none? That doesn't cancel, Adam. Now, if this, you can't factor x to the 4th plus 1. You could factor x to the 4th minus 1. But you can't factor x to the fourth plus 1. You could only factor this if it was x to the fourth minus 1. Because it's difference of two squares. Remember, we can't do sum of two squares. We can do sum of two cubes, but we can't do sum of two squares. We can only do difference of two squares. So there's no hole there. It's an asymptote. Yes. How about horizontal asymptotes? You got to do the slant. There is a slant asymptote here. And the slant asymptote here is going to be a cubic, so gross, right? X plus 1 goes into x to the fourth. I'm going to put my placeholders in here to kind of help me out. Oh, you could do synthetic. That was a good call, y'all. Y'all were jumping on that. 3, 2, 1, constant. Ooh, not too fast. 1, negative 1, negative 1, positive 1, positive 1, negative 1, positive 1. Nope, negative 1. Yeah, this doesn't matter. Ooh, what does that mean if it's alternating? It's a bound. It's a bound. Lower bound. It's the lower bound. All right. So this means my slant asymptote is y equals x to the third minus x squared plus x minus 1, which is a cubic. Yes. You will not be without your calculator on one like this. So you would be able to graph this and look. You won't be without your calculator on one like this. Yes. Not right now, no. This is a sketch right now. This is a sketch right now. Right. How about the domain here before we graph? Because there was a vertical asymptote negative 1. Let me see, is there anything else before we graph it? We'll need to graph it to do range. In behavior here, I would base my in behavior on this. So the in behavior here, yep. So the limit, because that's odd and positive, the limit as x approaches infinity of f of x would be positive infinity, and the limit as x approaches negative infinity of f of x would be negative. What about it? So that's not in behavior, that's the definition of the vertical asymptote. Okay. Will you have to do that right now? No, but will you have to know what that means for specific questions on your test? Yes. So in other words, if I told you find the vertical asymptote and define it using limits, that's when you would say, okay, there's a vertical asymptote here. That means that the limit as x approaches negative 1 from the left of f of x is, and the limit as x approaches negative 1 from the right of f of x. And I'd have to look at the graph to see if it's going up or down on either side. Unless you want to plug some values in and check them. Yeah. No, I looked at once I had divided it, because remember, what we did before was we looked at the very first term. The positive or negative, the even or odd with the degree, right? And so I looked because this is what you get when you divide this. So this equals x to the third minus x squared plus da, 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 right? So I can look at just the first term here and it will tell me what the end behavior is doing of the whole thing. Mm-hmm. Positive and odd. Yep. Yes, but you might get confused if you don't zoom out or in enough to where you can see the ends because there's all kinds of funky stuff happening in the middle also. As long as it's not negative in front. Remember that little. So I always think of odds being something like a line with a positive slope or a negative slope. So this would be odd, positive, odd, negative. That's what the ends would do. I always think about the evens as being a quadratic because both ends go the same way. So a positive, both ends would go up, and a negative, both ends would go down. Despite whatever else is happening here, that's what the ends are doing. Leading coefficient. If I ask you, write the vertical asymptotes in terms of limits, that's when you would do this. The positive. Say that again. Both ends would go negative infinity. So if it's negative x squared, think about a parabola that's opening down. Yes. No, because I don't have time to do a whole nother one. What's your question about that? So if you divide them, what degree do you get when you divide? So if you do x to the fourth plus 1, and then inside you do x to the 8th plus 1. X to the fourth would be 4.